Offer. I did our still look.
Alright, no problem. Hey guys, Nathaniel here. In this video, we are going to make an automated door lock for your home, which can be connected to your smartphone or your laptop. Multiple devices can be connected to this door lock using different emails and passwords. This project was sponsored and inaugurated by my brother Shion. So let's get started. To make the door lock actuate, we are going to be using a high-torque servo. This particular servo has metal gears. We basically want to make sure that it's a standard size servo and has 35 kilogram 10 meters of torque at 5 volts. So first, we're going to be making our door lock connector piece with the kit that came with our servo. Then we're going to make sure that our connector piece fits our door lock accurately. Then we'll nail the kit that came with our servo on our connector piece so that it's stagnant. So now we're going to be making the housing for our deadbolt connector piece, which when we measure will fit the door lock and also fit our servo. Then after putting everything in place, we paint and leave for a couple of minutes to dry. This is the main material in our project. It's called a Raspberry Pi 4. We're using the Raspberry Pi 4 because it has inbuilt Wi-Fi and can be connected to the internet. You can use any other Pi so far it can be connected to the internet. So this is how we're connecting our Raspberry Pi to our television using HDMI port, and this is what is displayed in our Raspberry Pi on our television. And this is an external keyboard and an external mouse, which operations can be done on our Raspberry Pi, and we can even run our server on our Raspberry Pi. But we'll be choosing to do our operations from our laptop by connecting our laptop to the Raspberry Pi using SSH over a local network and the IP address of the Raspberry Pi. If you don't have SSH enabled on your Raspberry Pi, I suggest you go back to the documentation of the Raspberry Pi and enable SSH on your part. These are the wires for our servo, which will be connecting to our Raspberry Pi GPIO pin. Then this is the red wire which goes to pin 2 for 5 volts. White is the control, which goes to pin 11. Then black is the ground wire, which goes to pin 9. We want to make sure to put our wires in the right pin so that we will not damage our Raspberry Pi. So this is the folder that contains the code for our Rust server, and these are the dependencies used in our Rust server. And first here we have Tide. Tide is a Rust web application framework built for rapid development, and since Tide works with Rsync STD, we are using it as our asynchronous runtime. Then next up we have JSON Web Token for the authentication process for our server. Then setday is for serializing and serializing. Setday JSON similar is a crate for serialization. Then next up we have this error. This error is for the error management for our server. Then chrono is for the time management, because we also have expiration for our token. That's the token generated anytime you log in. Then we have our Prisma clients and our Rust GPIO 0. That's for the GPIO pins for our Raspberry Pi. Then you have OpenSSL, OpenSSL sales. Then Rust Argon 2 for the password hashing for our server. Then the More. Also, in our Rust server, there are like 5 emails that has access to the login handler that will generate a token. That means only 5 emails can access the action open or action close for the door lock. Any other email sends a bad request. Our server is meant for my home, so 5 emails are enough. So if you can see here, I implemented calls, that's cross-origin resource sharing. I had an issue with running my Rust server and my client on the same computer, so I had to implement calls for my framework, which is Tide. If you're using another framework, I suggest you search for how to use calls for your framework. So now we want to rsync this whole code to our Raspberry Pi. We want to copy this whole code and send to our Raspberry Pi. I was cross-compiling our code and sending the binary format to our Raspberry Pi before, but due to some errors I had with the Prisma engines, I had to manually implement the right path, and I had to install some other external dependencies needed. So we want to create a new terminal, then we want to seed it into our front end, our React client. We want to seed into the client. Then we want to seed into the client again. They want to start our client on our laptop. We want to run it on our laptop. So if you can see, everything redirect us to our React app, and you can see open door from your home, sign into your account. This is my email and my password. Once I sign it redirects me to another web page where I can access open or access close. But right now this doesn't do anything because our Rust server is not running. We want to run our Rust server on our Raspberry Pi first. And if you check the React, you can see where it is running, and if you type this on your smartphone on any search engine, you can access the client and open and close the door from your phone. So now that we've Rsynced our whole code to our Raspberry Pi, we want to run our server on our Raspberry Pi. So we want to SSH into our Raspberry Pi over a local network. Pi is the default name for our Raspberry Pi. If you change your SSH, you change it also, then add your Raspberry Pi IP address. So now we want to seed it into our code, then seed it into the SRC, then cargo run our server. You might need to set the environmental variable for the Prisma schema to the right path because we're using Prisma. So now we can see a message that our server is running. Then if we go back here, then access our door, we can close, then we can open, we can close again. So as you can see here, our server is still running, but after a while the connection breaks. But we want to make sure that our server is constantly running on our Raspberry Pi so that our client is accessible at any time. So what we're going to do is that we're going to create a new terminal, then SSH into our Raspberry Pi. Then we're going to create a file, your server.service, in that path, then sudo into it. And as you can see here, I wrote some commands for our server with the description of your fancy server, then the working directory on Pi code. That's where my Rust server is. If you need to change yours to the right path also, so we're just going to save this, then we're going to use systemctl and use daemon reload, then it asks for our password, type our password. So now that that one is complete, we're going to enable our server so that it is constant, it is active at all time, running at all time. So type our password again. Then it says it is required, our password is required to start our server. Then now the authentication is complete, so now our server is running at all time. After mounting our doorlock connector piece on our doorlock and our servo wires are connected to the GPR pins, and we've tested that the client works, we want to mount our Raspberry Pi on our door close to our servo, and make sure that while mounting your doorlock connector piece, you're mounting it in the right direction in which your door is locking and your servo is turning, so that it does not damage your servo rotor. So now we're fully mounted our Raspberry Pi and taped some wire so that the wire does not pull out while opening the door. And I also added this automated door closer so that you know that okay, our door is always closed, and then we can turn our servo and lock the door. Okay. is where I'll be powering the Raspberry Pi. It is wired from upstairs. We have constant supply of electricity using inverter, so we also have constant Wi-Fi. If you want to make your own project, your own setup like this, make sure you have constant supply of electricity and constant Wi-Fi so that your client will be running at all time. So now I'll be testing the client on my smartphone, and if you can see, that's the IP address and the port in which my client is running on. So first I want to sign in, then let me lock the door. As you can see, if it's locked and then I unlocked it, let me show you a better view. As you can see here, lock, unlock. Let me increase the speed in which I lock and unlock it. Lock, unlock, lock, unlock.
So you said your name is Nathaniel, right?
Yes, Nathaniel Bajo.
How old are you, young man?
17.
17?
Yeah.
Tell us a little bit about your programming journey.
When I was still in school, I was learning HTML, CSS, and JavaScript, and I did some websites with it, and with Bootstrap. Also, the front-end languages, so I just websites and some other basic things. Then I left school and started learning Rust.
Oh wow, Rust.
Yeah,
cool.
Rust programming language.
So why did you build this project?
Because it's been a year learning Rust, and I wanted to put what I've learned into practice, and this was the most current issue we had in our house.
What are the stacks for this project?
We have the Raspberry Pi 4, we have the high-torque servo which actuates the door lock, we have our Prisma libraries and engines that hold the database for our Rust server.
What were the obstacles in setting up this project?
At first it was the servo. I thought the Raspberry Pi could not power the servo because it needed 5 volts to power the servo, so I was soldering external batteries, all those 1.5 volts together. But then after reading the Raspberry Pi documentation, I saw that okay, there's a pin that can power for 5 volts. Then the other one was the Prisma engines, which almost made me use Diesel database for my server. The Raspberry Pi is not compatible with the Prisma engine binaries, so I had to manually implement the binaries to the right path so that my Rust server could work, and it did work.
The errors you encountered while programming, how do you fix them?
As my brother would say, use Google answers all. What I would do is that I would search for the errors online on Google, and I might not see the answer at first search, but if I follow the path to where the error led me to, I might find the answer. Or I would search for similar things, the topics that brought up the error, and I would form my own answer from it.
What made you think programming was the right choice?
Because since when I was small, I've always loved tech and anything computer based, and now I'm older, and when it's 21st century, tech is taking over, tech is in charge right now, and I said okay, let me join tech and help the world, make the world a better place. And even though it makes an impact in just one person, we are good to go.
After your project, what next?
I'm still going to create my own personal app for my projects using Flutter, so that I'll not just be able to connect to my server, my Rust server, with the local network. I'll be able to connect to it from anywhere, and which will make the projects complete, and my door lock will be easier to use. After my project, I'll be learning substrates and looking forward to work with people and companies build projects, build my career more, all that fun stuff.
So what's the motivation behind this project?
That any little idea can be used and any little issue can be solved. The issue we had was the door downstairs, opening and closing the door every time because it's far. So if you want to get the whole materials needed for the project, you can get them on Canna Kit. Thank you guys for watching this video. I hope you guys enjoyed it and hopefully you can use this knowledge to make your own project. You can contact me on Instagram at natty_baju, that's NATTY_baju. I'm also available on Twitter at Nathaniel_baju. I'm available on GitHub at Natty Baju, then LinkedIn at Nathaniel Baju. Thank you very much.